Hey everyone, so welcome to today's lesson. Today's lesson is lesson 1-2, and in this lesson we're going to be learning about three different properties: distributive property, the commutative property, and the associative property. So we got three properties to work with. Our learning objectives for today is to apply the distributive property to an algebraic and geometric approach, to identify the associative and the commutative properties. And our language or objective is to explain, in our own words, the process when using the different properties. So let's take a look at our do now. Okay, hey guys, so let's look at our do now. For our do now for today, it says evaluate each. So I want you guys to pause the video, try these three problems on your own, and let's see if we get the same answer. I will walk you through it after you try it yourself. So pause the video. Okay, so this is what you should have done. For number one, I'm using order of operations. So I see PEMDAS, I see parentheses first. I'm going to add that inner parentheses, which is a 5, and then I'm going to multiply it, giving me a 45. For number 2, oh my god, that one's the easiest. I'm not sure why I even put it here, but 11, you're just adding those. For number 3, same kind of thing as number 1. You see parentheses, do that first, gives you 5, and then add 9 plus 5, giving you a value of 14. So really, really easy, getting again our minds back at this math that we have to do. So let's look at our thinking question for today. It says, how do we use the distributive property, the commutative property, and the associative property? So there's three properties that we're going to talk about in the first page, and then we're going to focus on one of the three. A quick run through. For the first one, we have distributive property. Now, you guys have done distribution in your past math careers, and I'm just going to define it again. The distributive property states that you can multiply a sum or difference by multiplying each term separately and then adding or subtracting the product. Here we have the distributive property states if A, B, and C are real numbers, then A parentheses B plus C is equal to, I'm going to apply that distribution and I'm going to multiply whatever's outside, the first term inside, plus whatever's outside with the second term. So giving me a value of AB plus AC. We're not going to be dealing with just variables. We'll have some numbers to do. So let's say if I had a subtraction inside, I would do the same thing. I will take that A multiplied by that first term B, subtract that A times the second term C. So we have AB minus AC. Next property, the commutative property. The commutative property states that the numbers on which we operate can be moved or swapped from their position without making any difference to the answer. The property holds true only for addition and multiplication. It does not hold true for a subtraction and division. Commutative property. When I think of commutative property, I think of something commuting. Commuting means to move from one place to another. So in simple terms, we have two variables, right? We have an A and a B. They're real numbers. So in the first one here, I have A plus B. If I move that A and B, so if I swap the position, I'm still going to get the same answer. So let me just think on the side. Let's say I said 7 plus 1. You all know what 7 plus 1 is. That's a value of 8. But that's the same thing as me saying 1 plus 7. Is 1 plus 7 not 8 also? Yes, it gives us the same exact value. So swapping those two numbers doesn't affect our final answer. The same thing occurs with multiplication. If I have A times B, if I move those and swap those variables, I get B times A, and it's still exactly the same answer. So let me just think on the side. If I have 7 times 1, 7 times 1 is 7. What if I swap those numbers and I say 1 times 7? 1 times 7 is still 7. By me moving those two numbers, nothing has changed. The answer is exactly the same. So that's our commutative property. And our last property, associative property. The associative property states that when 3 or more numbers are added or multiplied, the sum or the product is the same regardless of the grouping of the addends or the multiplicants. We're talking about some sort of grouping together. Associative property. I'm associating myself with certain groups. So let's look at our definition in terms of variables. If A, B, and C are real numbers, then A plus parentheses B plus C is equal to, so let's say B and C are friends and A is on the outside. All of a sudden, A plus B become friends. And now C is on the outside. The order does not change. If you notice, there's an A, a B, and then a C. In my second piece, I have an A, a B, and a C in the same order. What changed here is my grouping, my parenthesis piece. It started off in the back and now moved towards the front. Same thing occurs with multiplication. I'm not giving an example here. I'm just going to just write it out. So we have A times B, they're a group now, times C. The order does not change. A, B, C, A, B, C, D, E, F, D, E, F. I should see the same exact numbers in the same order. The only thing I'm going to see different is that parenthesis, that grouping piece. So let's do some problems dealing with those three properties. So here we have, you are given two linear expressions. List the properties that have been used. So here I have my first expression, parentheses 4x plus 2 plus parentheses 3x plus 1. What happens? The parentheses get dissolved, which is making me think I see parentheses and then I don't. So somehow nothing has changed, right? 4x, 2 is second, 3x, 1 is third. I have some sort of associative property here. How do I know it's some sort of associative property? Because the order of all those four numbers and variables have not changed. So now I'm going to focus in the second one. Now I have a 4x plus 2 plus 3x plus 1. And then they give me 4x plus 3x plus 2 plus 1. What happened there? Things got moved around. Anytime something gets moved around, we're dealing with the commutative property. So we have 4x plus 3x plus 2 plus 1. And then I get 4x plus 3x in parentheses plus 2 plus 1 in parentheses. Again, all of a sudden, those parentheses came back, making my grouping associative. There is no distribution here because I'm leaving distribution for our next problem. So you're going to see times in which they give you a list where you have one expression and somehow it makes it to the second. You want to think of what has happened. Have you distributed? Have you associated? Have you moved grouping symbols? Have you moved numbers around? So those are our three properties. And now we're going to focus on page 2, our favorite property. We love the distributive property. So it says, how do we apply the distributive property? So we already have seen that the distributive property means that you take that coefficient in front of the parentheses and you multiply to everything that's inside the parentheses. We could do it using arrows, as I have here, or we could use some geometric approach. When we're using a geometric approach, what you're going to do is put what's outside in front here. So in this case, an A. What's inside the parentheses, you're going to put on top of the box. So a B and a positive C. I always put positive C or negative C. What occurs here is you're going to multiply. It's the area model. So you're doing A times B, A times C. I'm going to do it again here. Whatever's in front of the parentheses goes in front of the box. B minus C. I should put a positive here. So I have A times B and A times negative C, which would give me a negative AC or a minus AC. So let's try this. We're going to use a mixture of this. We're going to just use the arrow method and then we're going to apply the geometric method. So for number 1, using the distributive property, I see the 2 and I'm going to multiply that 2 to everything. So I have 2 times x plus 2 times 3. I'm showing my work here just so you see it more clear. And that will give me a 2x plus 6. For number 2, I'm distributing that 7. So 7 times 3a plus 7 times 4. 7 times 3 is 21. So that means a 21a. 7 times 4 is a 28. Can I jump from here to here? Of course, I'll do that in the next one. So I have 8 times n and 8 times 3. 8 times n I know is 8n, and 8 times 3, or 8 times negative 3 is a negative 24. I don't need to show that in between work, but I do need you to understand that that is what's occurring here. Let's go to the next. So for number 4, we have the area model, it looks like. So whatever's in front of the parentheses is going to come in front. What's inside the parentheses is going to go on the top. So we have an x and I have a negative 2. I treat that as a negative 2 instead of a minus 2. So in my area model, I'm going to multiply that 5 times x, that negative 5 times x, so negative 5x, and I'm going to multiply negative 5 times negative 2, giving me a positive 10. So our answer is negative 5x plus 10. Be very careful there. We have negative times a negative. Let's do another one. Negative 6 comes outside. The 2 minus n comes on the top. Do not change the order. Leave everything exactly as it has been given. So first thing I'm multiplying is the negative 6 times 2, giving me a negative 12. The second thing I'm multiplying is the negative 6 times negative n. So we have negative times a negative, automatically a positive. 6 times n, 6n. So my answer is negative 12 plus 6n. Again, I'm going to leave that exactly as it is. Let's do one more area. So number in front of the parentheses comes in front. We have a 3a and a negative 2. So I'm multiplying negative 7 times 3a, negative 21a. Negative 7 times negative 2. That's right, positive 14. So my answer is negative 21a plus positive 14, or plus 14. Box it up. Let's go to something that looks a little more complex, but it really isn't. So I'm going to do my arrows here. You could, if you want to do your area model there, you can as well. So I have 4 times b is 4b. 4 times 2n is 8n. For the next one, I'll show the work. So I'm multiplying. I'm still doing my arrows here. I have negative 4 times 3b minus 4 times negative 2n. If you notice, I put it inside parentheses for a reason, because if not, I get confused. So I have a negative 12b, negative 4 times negative 2n, positive 8n. And the last one, I want you to pause the video and try it yourself. Okay, so you should have gotten negative 4xy plus 8. Now that we did those problems, here's our quick summary. It says you have 3 important properties that we use in algebra. We have the distributive property, which is the most famous property, the commutative property, which means we're moving things, and the associative property, which means that our grouping symbols are going to change or be associated with different things. When applying the distributive property, we need to remember to multiply the number or variables in front of the parentheses to every term inside the parentheses. Our famous distributive property is going to come back over and over again.